Hello, statistics and pre-calculus. So you should have just watched a video of us working through an exponential growth word problem together. This time we are doing an exponential decay. What is our signifier that it's going to be a decay problem? We have this word depreciates. So depreciate means loses value. So in the course of this class, that's going to indicate that you have an exponential decay. So remember, same general formula, a times 1. Instead of plus r, we have minus r, right, to the t. Everything else is the same. This is still the end, the start, the rate, and the time. We just changed that sign of our rate, right? So, again, next step in this problem is to determine what are we looking for. It says find the number of years. Number of years sounds a whole lot like time. The time is what we will be solving for. So we just have to sort of plug it in. So we have our computer starts off valued at 2765, and then it ends up at 350, and the rate of depreciation is 30%. So it starts at 2765, so that's our A, and ends at 350, that's our Y. And I'm going to move my paperweight a little bit, sorry they can no longer see it. And then it tells us our rate, R, is 30%, or 0.30. And again, we don't know T, so that's our unknown. That's what we're looking for. So at this point, remember, we're no longer going to just be solving it using our calculator solve function. You can use that to check your answer, but you actually want to be able to put this in a log format so that you can get your answer. So first thing we want to do, of course, is divide both sides by our A, which is 2765. So when we do that, we should get 350 divided by 2765 equals roughly 0.126. That equals 1 minus 0.3 is 0.7 raised to the t, right? At this point, we just need to rewrite this in our log format, right? So in this case, our log of base, so base is this guy here, right? Base is what we're raising the exponent to, of the answer 0.126 equals the exponent t. So our rearrangement here is log of 0.7, log base 0.7 of 0.126 equals t, and we should get that t equals 5.8 years. Or we can just round that up to a nice and even 6 years. So, what is the number of years it will take for the computer's value to be 350? That would be approximately 6 years. So, if you're still confused about how to rewrite these guys, I want you to go back and watch the logarithms video, where I do a lot more examples, but here we're kind of operating based on the assumption that you already understand this pretty well. So if this part confuses you, go back, make sure you understand this, and again, use your solve function or Wolfram Alpha to check your answer. Alright, so then we have our next part. What will the computer be worth after 2 years or after 12 years? And again, this is like the easiest thing we can do in this unit, right? So all it's asking us to do is find the end, which is y. So really we're just going to use our y equals equation, and we already have all of our pieces, so we don't have to use a solve function, we don't have to do cubic roots or exponents or any of that. We literally just have to set up our equation correctly. So our end at 2 years, so I'm going to say y sub 2, is going to equal where we start, which again was 2765, times 1 minus, because we're depreciating, 0.3, because our rate was 30%, raised to whatever year, in this case 2. So we should get, all we have to do now, plug into our calculator, 2765 times 0.7 raised to the second power. So after 2 years, our computer is worth a whopping $1,354.85. And again, same kind of deal for finding after 12 years, only difference here, instead of y sub 2, we have y sub 12. So y sub 12 equals, again, 2765 times 1 minus 0.3, or times 0.7, raised to the 12th power. So here we can literally just go Control-V, copy-paste, and then just go add a 1 right in front of this 2. That's going to give us our answer, which is that after 12 years, our poor computer is only worth $38.27. Alright guys, good work. See you for the next video.